Hello students, in this video we will check what are the different types of beams, different types of supports and different types of loadings. Let us begin with the different types of beams. So we have the types of beams. Let us see one by one. So we have something known as a simple beam. Simple beam. A simple beam can be simply formulated by keeping two fingers and keeping a scale on it. That makes a simple beam. Let's also consider it diagrammatically. So we have a beam and we have two supports which are controlling that beam. This is known as a simple beam. Let's go next. Second, we consider something known as a cantilever beam. Cantilever beam. Now, a cantilever beam is usually seen in our balconies. So, balconies will have cantilever beams. It simply says that it is fixed at one end and free at the other end. It does not have any other support. The third that we can talk about is an overhanging beam. Overhanging beam. Now, an overhanging beam is when a beam extends beyond two supports. Then it is termed as an overhanging beam. Fourth, what we can consider is a continuous beam. Continuous beam. In this case, the beam, it extends on various supports in the middle. So, this is known as a continuous beam. Okay, from here let's go ahead to what are the different types of supports that we are going to study. So, types of supports. Types of supports. First type of support that we are going to be talking about is known as a roller support, which is drawn this way, or a rocker support, which is drawn this way, which symbolizes a rocking chair sort of situation. In this, let us see what are the number of reactions. So, in both these types of supports, you can just show a beam over here. In both these types of supports, you are going to get one reaction. This one reaction is always going to be perpendicular to the support. Therefore, in this particular case, we will get one reaction which is going to be vertical. Let's consider that this is point A. Then we will term this particular reaction as vertical at A. Now, let's go ahead with the second type of support. This particular thing, as I told you, is known as a roller support. And this is known as a rocker support. Rocker support. Let's go ahead with the second support. This is known as a hinge support or a pin support. So, hinge or pin. Now, in this, the number of reactions are always two. So, we have one vertical reaction and one horizontal reaction. Say we name that this particular point is, say, some point P. So, this will become vertical at point P and horizontal at point P. We have to understand that what are these reactions? These reactions are nothing but the resistance to movement. For example, if our parents tell us that you have to study the whole day. So you study the whole day and after studying the whole day, you request your parents that you want to go and watch a movie. If your parents say yes, go ahead and watch a movie, then you are not going to show any resistance. You will be happy and you will go ahead. But in case they say no, you may show a reaction, you will show a reaction saying that I have studied the whole day as you have said. So now why are you not allowing me to go for a movie? So this particular reaction occurs at the places where movement is not allowed. So in a rocker support and a roller support, the movement along the x direction is freely allowed and rotation around the point is freely allowed. The reaction comes in the y direction where the movement is not allowed. Similarly, for a pin joint, the two reactions that are coming, one is vertical and one is horizontal. This is because in this particular type of support, only a rotation is allowed. Let's go ahead with the third type of support, which is known as a fixed support. So this is how it is drawn. This is called a fixed support. Now in a fixed support, we will always get three reactions. So one will be vertical, one will be horizontal, and one will be a moment. Now let's consider this point. If there is a force acting on this end, this beam will try to turn or try to move in the downward direction, but this particular support has to avoid its movement. Therefore, it will give a reaction in the opposite direction, that is anti-clockwise. It will try to give an anti-clockwise moment. So the reaction that will come over here will be an anti-clockwise moment. Therefore, we show an anti-clockwise moment over here. Say, let's say this point is say B. So this is vertical at B, horizontal at B, and moment about point B. These are the three unknowns. Let's go ahead and now understand what are the different types of loadings. So types of loadings. Now, in what are the different types of loadings? First of all, we have something known as a point load, which we have already studied earlier. So a point load can be indicated by a arrow. Say I say it is 50 Newton. So a 50 Newton point load is acted upon some point. So the value will have to be kept as the same. We do not have to calculate any equivalent value of it. The second type of loading that we can consider is a moment. This is also what we have already seen in our lectures earlier. So a moment is always drawn by a curved arrow. Say this is 50 Newton meter. So this is a moment. The third type of loading that we will find in our different questions is known as a UDL. Uniformly distributed load. UDL, uniformly distributed load. Now, this particular type of loading can be drawn either this way or it can be drawn this way. They both symbolize the same concept. Now, let's say that the loading is spaced on 2 meters. Each of them. Say I have a intensity of this loading as 10 Newton per meter. This simply says it is 10 Newton per meter. So if it is 10 Newton per meter, so for 2 meters how much will I have? So it will be nothing but 10 Newton per meter into 2 meters. Here the meter gets cancelled and you get a point load of 20 Newton. Now we have to try to understand one thing very clearly, is that this particular 20 Newton conversion that we have done is only for the sake of calculating the support reactions. The value of or the loading condition does not turn into a point load. It actually remains as a UDL on the entire beam, and further calculation, just for further calculations of calculating support reactions, we have to convert it into a point load. Therefore, we show it as a point load in the form of a dotted line. So we show, and this particular dotted line we have to show at the center. Why we have to show this at the center is because the loading is uniform and therefore the value will lie at the center of the given span. The next loading that we have is known as uniformly varying load. In this particular case, the loading is varying, but it is varying uniformly. So it forms into a triangle. So you have a length of the triangle, say it is 3 meters. Say you have a 6 kilonewton per meter loading here and you have a 0 kilonewton per meter loading here. That means your intensity is beginning from 0 and it is extending till 6 over a span of 3 meters. Let us now consider what we can do as a conversion of this. Since it looks like a triangle, we can take the equation of area but not considering the height but considering the intensity. So half base of the triangle is 3 meters and height, which is given here as an intensity, that is 6 kilonewton per meter. Here again meter will get cancelled. 2 3s are 6, so 3 3s are 9. So you get a point load of 9 kilonewton. Again you are taking the point load just for the sake of calculating the support reactions, but on the beam the loading will continue to remain as a triangular loading. Now when we are placing the point load on the triangle, we have to place it at the point where the center of gravity will lie. Not exactly, but at least the base. So that will be 1/3 from the perpendicular side. So that is 1/3 of 3. That comes out to be 1 meter from the perpendicular side. So we will get the point load over here, which is nothing but 9 kilonewton. This is a kilonewton. So 9 kilonewton. Okay. Now this is the value. Now what we have next is a trapezoidal loading. Trapezoidal loading. Now this trapezoidal loading is nothing but a combination of a UDL and a UVL together. So you have it something like this. So you have a triangle plus a rectangle. Now how will we convert these values? We are converting these values. Say for example, we take the same span of 3 meters. Here you take the span of 6 kilonewton. Say we take a span of 2 kilonewton over here. So now our loading has some intensity at the beginning as well as a higher intensity at the end. We have to now convert this into point loads for our calculation. So what we can do here is we can clearly divide this particular loading into two parts. One will form a triangle and the other will form a rectangle. For the rectangular loading, we have the conversion as length into breadth. So that will be 3 meters into the intensity, that is 2 kilonewton per meter. Here meter gets cancelled. So you have a loading of 6 kilonewton. Now this 6 kilonewton will act at the center because we are talking about a uniformly distributed load. So that will act at the center and this value comes out to be 6 kilonewton. Since it is at the center, it will divide the loading as the distance as 1.5 meters and 1.5 meters. On the other side, what we are going to do is we are going to take a triangular loading, and the triangular loading we can just use the equation of area just for the sake of simplicity. So that is half base is 3 meters into the height. Now we have to understand that the height of this triangle will not be 6. The height of the triangle will be a deduction of this value. This particular value of 2 kilonewton has to be deducted because 2 kilonewton has already been considered in a UDL. Therefore, now we have the remaining height of 6 minus 2, that is 4 kilonewton per meter. Again, meter gets cancelled. 2 2s are 4, 3 2s are 6. We have a 6 kilonewton loading again. Now this 6 kilonewton loading will act at 1/3 of the triangle from the perpendicular side. Therefore, this loading, let me show it to you in a green pen. This loading will be at a distance of 1/3 of the entire 3. That means 1 meter from the perpendicular side and 2 meters from the other end. So again, this calculation of 6 kilonewton and the calculation of the other 6 kilonewton are totally different. One is a UDL, the other is a UVL. This is how we convert the different loadings that are given to us into point loads only for the sake of calculations. When we apply it on the beam, they still continue to remain as the loadings that are given. Thank you.